What's up, YouTube? OptoInfo back with another leaky video. Check it out. This week is going to be the first video in a series of what I'm calling OKAP Optics. Okay, for all you opto residents out there, we've got OKAPs right around the corner. Annoying test, reminiscent of step one. Anyhow, we all got to take it. How can you do well on it? How can you improve your score? One way is to kill the optics section, which everyone struggles with because it's not clinically relevant for the most part. Anyhow, so how can you do that? How can you do well on the OKAPs? Well, just do these questions. I got 25 questions here. We'll walk through them together because I know it's painful. We'll walk through them together week by week. I'll break it into like 4 weeks, 4 different videos. And then you have this down pat. I guarantee you get a 75 percentile or better on the OKAPs. How can I guarantee that? I can't in reality. But this was pretty much the extent of my knowledge when I took the test last year, and that's what I got. So let's walk through it together. I know I need a refresher, so it'll be good for me as well. And I'll give you little tips and tricks that I've come up with or been told, and maybe you'll like that too. But in any case, do these questions. You'll come up with your own style. We're not going to focus so much on the abstract concepts because that's hard to translate into getting a problem right when you're in a time crunch on a test. Okay. I got to give props to Dr. Sichelman. He's the one who came up with these questions and the answers and the philosophy that you got to drop all this concept stuff. It just doesn't work in this setting for residents trying to perform on a test. Just do these freaking questions, know the formulas. In my case, I'm going to say know more of the pictures. I do things in a picture way that sort of supplement the formula. So it's hard for me to remember equations. Anyhow, let's walk through it together. I'm going to put the questions. I'll try to make a PDF and put them in the link below, in the description below rather, and we'll go through it. We're just going to do the first 7 problems today, and we'll go from there. All right, enjoy. Peace. So we're doing number 1 here. So what are we working with? Ignore that. That's wrong. An object is 25 centimeters to the left of a 3 diopter concave lens. Where's the image? Where's the is it magnified, minified, real, virtual, upright, inverted? We're going to figure out all these things for essentially 1 through 4 here, and it's just different distances and different mirrors and or different type of lenses and then mirrors. So let's get to it. So after I've drawn my line, step 1, step 2, I drew my mirror or lens. In this case, it's a 3 diopter concave lens. So a concaved in lens is going to be like that. And it's 3 diopters, so we know this is going to diverge things, so it's going to be a -3. That's our D. It's just forming my picture here. I always draw that first. Now I just immediately draw my distance in object, and we're going to have this distance is what? It is 25 centimeters. I immediately convert it to meters. That's just my style. And then I immediately flip that and invert it into a divergence or a vergence. Okay, and so 1 over 0.25 is going to be 4. It's going to be negative though because everything's diverging away from our object initially. So -4 is going to be our U plus D equals V. So -4 plus -3 equals -7. Immediately invert that back into a distance. 1 over 7 is whatever the heck that is. 1 divided by 7, 0.14 meters. Okay, so do I draw it to the left or the right though? Well, for that, we look at the sign. It's a negative, so negative is to the left. That's sort of intuitive for some reason for me. So 0.14, well, that'll be something like that, maybe 0.14 meters. Okay, but now is it upright or inverted? And is it magnified, minified? For that, we do our magnification formula, which if you may already have it committed to memory, which is magnification equals U over V. But for me, I just use my picture again. I just draw a line right here, and I don't have to memorize which is on top of which. I just draw a line through my D, and that sort of makes a division quotient or backslash for U over V. So -4 over -7. It's going to be a positive number, so that's going to be upright. So it's going to be upright. So I draw a little stick here, upright. And then is it going to be magnified or minified? Well, -4 over -7 is less than 1, so it's going to be minified. So it's going to be 4/7 of whatever this is. So, so yeah, there you go. one other thing. So I wanted to mention about the sign. So this, I use this to tell you, okay, for a lens, a negative means to the left, which seems intuitive, and it's just the opposite for a mirror. A negative for a mirror, if this was a mirror, it would be a negative would mean to the right. It does tell you one other thing, and that's about if the image is going to be real or if it's virtual. And what I'll tell you for that is that this is the same for both mirrors and lenses, and it's also sort of intuitive. If you imagine light rays just diverging, okay, so just as a snapshot of some divergent rays, that are going out. When these are diverging, so this is a negative vergence here. When it's negative, when do these ever form an image? When are they going to form an image? Never. These divergent rays or negative V's, doesn't matter if it's a lens or a mirror or whatever, if light rays are diverging away from one another, they're never going to, to form an image, you have to think the light rays have to come together and intersect. And boom, then you have an image. There's your image. But if they're always diverging, then they never form an image, unless it's a virtual image and you have to do that thing where you trace it back and they all intersect right there. And then there's it's a virtual image. So negative. So there's two things. The sign tells you two things. It tells you if it tells you if it's to the left or to the right, which is opposite for lenses and mirrors. And then it tells you if it's virtual or if it's real, which is the same regardless of anything. Okay. So on to number 2. So what do we got for number 2? For number 2, we got same type thing, different distance, different power, different type of lens. We got to figure out all the same stuff. All right, so let's draw it out. What do we do first? We draw our line. Whoop. What do we do second? We draw our lens. This is a convex lens as opposed to a concave one. So convex, that's going to be like this. Okay, so we know this is going to converge light rays. That's going to be a positive whatever power. In this case, it's going to be a +4 diopter lens. Okay, so this is our D in our U plus D equals V formula. Okay, so in the object's 50 centimeters to the left, so I always just draw my little distance thingy and convert it immediately to meters. That's just my style. And then I next draw my arrow. And so what are we going to do to figure out all this stuff? Well, we got to use our equation. So first, we go ahead and invert that into a divergence or a vergence. So 1 over 0.5 is going to be 2. It's going to be diverging, so that'll make it a -2. Minus U plus D, -2 plus 4 will give us +2. And we can invert that back into a distance immediately. 1 over 2 will be 0.5 meters. So it's going to be to the left, to the right. Well, again, what do? We look at our sign. Our sign is positive. That means it's going to be a real image to the right. So we'll do another 0.5 here, 0.5 meters. And then is it going to be upright or is it going to be inverted, and is it going to be magnified or minified? So for those, we use our magnification formula, which if you know it, you may have it memorized, but if you don't know it, then it's easy if you just cross out your middle, the number in the middle, cross out your D, and then you have the U over the V. -2 divided by +2 is going to give you -1. So -1, so the fact that it's negative means it's going to be inverted, okay, and then the fact that it's 1 means it's not going to be magnified or minified, so it's just going to be something like this. Okay, yeah, easy enough. Let's move on. Let's do number 3. So number 3, we've got what I do first, I draw my line. What I do second, I draw my lens or mirror. This is a 8 diopter concave mirror. So concave. So concave as opposed to convex. So it's caved in here. So it's like that. And it's going to be 8. A concave mirror is, assuming the object's going to be on the left here, light rays are going to diverge, hit this, and be converged to some degree. So converging things are positive in power. So this is a positive 8 diopter concave mirror. So and what is our distance? Our distance is we're on number 3. Our distance, that's our size, I'm sorry, is 20 centimeters. So that's 0.2 meters. Okay, and we can go ahead and I'll go ahead and label things. We'll go ahead and invert that into our vergence or divergence, object vergence, whatever you want to call it. It's our U. 1 divided by 0.2 will give you 5. Is it negative or positive? It's going to be negative, of course, because everything's always diverging away from our object. So the negative 5 plus 8 is going to give us our V, which is what? Which is plus 3. Okay, now we can go ahead and immediately invert this back into a distance. 1 over 3 is going to be 0.33 meters. Now, do we do 0.33 meters to the right or 0.33 meters to the left? For that, you look at your symbol. Now, this is a mirror, not a lens. So I always say this in my head, okay, this was the lens, the plus would mean to the right, but it's the opposite because it's a mirror, so it's actually going to be to the left, 0.33. So we'll try to draw that out here, maybe something like that, 0.33 meters. Now we'll extend our line. Now it's going to be magnified, minified, inverted, upright. For that, same formula. Magnification equals U over V. So negative 5 divided by positive 3 is going to give you a negative number. So that means it's going to be inverted. So it's going to be inverted, and then is going to be magnified or minified. Well, 5 over 3 is greater than 1, so it's going to be magnified by it's going to be 5/3 of this arrow here. So whatever that is, almost double. Okay, so that's our image, and it's going to be real because the light rays are actually going to pass through it, and also you have the positive. Okay, so let's move on to number 4. Number 4, what have we got here? This is well, first you know what to do. Draw your line. Next, what do? You draw your lens or mirror. In this case, we have a 6D convex. So convex, and not concave, but convex. It's going to be like that. And it's going to be, what do we say, 6 diopters. So that's going to be 6 up here. That's going to be our D. And is it going to be positive or negative? Well, if we have our object over here to the left, then it's going to hit this thing and hit this mirror and diverge away to some degree. So that's going to make it negative. You got it. So what's our distance next? Now we have our lens or mirror. Our distance is 25 centimeters. I immediately convert it to meters. 0.25 meters is our distance. And then I immediately invert this into a divergence or a vergence. 1 divided by 0.25 will be 4. So it'll be a negative 4 because it's always diverging away from our object. U plus D equals V. Negative 4 plus negative 6 will be negative 10. We immediately invert this back into a distance. 1 divided by 10 will be 0.1 meters. And do we draw to the left or the right? You tell me. Well, negative means to the left in lens, for lenses, but this is for a mirror, so it's going to be to the right. So let's draw 0.1 meter, something like that. It's going to be real or inverted. So for those, and then also it's going to be magnified or minified. For these two things, you do your U over V. So negative divided by a negative is going to be a positive. That's going to be real, my friend. I'm sorry, that's going to be upright. And then is it going to be magnified or minified? Well, it's going to be 4/10 of the original arrow. That's less than 1, so it's going to be minified. Something like that. Number 5, which combination of object and image is not possible with a convex mirror? So not caved in, but convex, like this. Well, oops, that's a lens. Let me do it again, right here. Not caved in, but convex. Well, we know that a convex mirror is going to diverge the whatever rays you're hitting it. It's going to bounce off, you know? So it's always going to create a negative vergence. Doesn't matter how close you get to it. So if it's going to be, this goes back to that number, to what I was saying earlier about a negative vergence. So if you always have a negative vergence, then you're always going to have a fake image, you know, because these light rays are never going to intersect. So you're going to have to trace them back and have this virtual image. So you can't have a real image with a convex mirror. You can understand it, or you can just memorize that. And I'll show you a quick diagram. So this is a neat interactive tool. I'll put the link in the description below. Let's flip it over to a mirror. The object is the candle on the right, and regardless of where I put this object, this candle, I'll make it a little bigger so you can see it. Regardless of where I put it, it always forms that virtual image to the left. Okay, this is just something new, a little concept question. So yeah, that's that. Number 6, what do we got here? An object is placed 25 centimeters in front of a concave spherical mirror. Okay. Oh, so this is different. We're given the radius of curvature as opposed to the actual dioptric power. So what do we do? Nothing different. We just do our same thing. We draw our line, then we draw our lens or mirror. In this case, it's a concave mirror. So it's caved in. And it's going to be a negative, a positive, because this is, if our object is here, some distance away from our mirror, then it's going to hit and converge, so it's going to be positive in power. And so the equation that we're being tested on here is essentially this, radius of curvature of 2 meters. So the formula that you have to know here is just that the power equals 2 over r, and r is in meters. So this is equal to 2 over 2 was the radius of curvature, which is equal to 1. Okay, so that's pretty simple. So plus 1 is our dioptric power. Okay, so now we just proceed as normal. Step 1, we got our lens or mirror. In this case, it's a mirror. Step 2, we have to get our distance. What's our distance? 25 centimeters. I immediately convert it to meters, 0.25 meters. Immediately invert that into a vergence. It's going to be a divergence, so which is our U. And in this case, 1 divided by 0.25 is going to be 4, and it's going to be a negative 4 because it's diverging. So U plus D equals V. Same old. Negative 4 plus 1 is going to be a negative 3, and then we'll immediately invert that back into a distance. 1 divided by 3 is going to be 0.33 meters. To the left or to the right? Well, let's look at our sign. Our sign is a negative. A negative, typically we're thinking about lenses. Negative means to the left, but this is a mirror, so it's the opposite. So it's going to be to the right. So to the right, 0.33. Try to keep it somewhat to size. And it's going to be also, remember, negative means that it's virtual. Diverging rays cannot form a real image because that requires them to intersect to form that image. Anyhow, and now is it going to be upright or inverted? Is it going to be magnified or minified? Again, just cross out our D. That gives us our quotient. Negative 4 divided by negative 3 is going to give us a negative number. Negative over negative equals a positive. So it'll be upright. And now is it going to be magnified or minified? Well, it's going to be 4 over 3, which is greater than 1. It's going to be 4/3 of our initial object. So it's going to be something like that. Okay, easy peasy. Moving right along. Let's do number 7. Number 7, we've got an object 50 centimeters away from a 12 diopter lens is moved 40 centimeters towards the lens. How far does the image move away from the lens? Okay, so Let's do our same thing. Should be getting boring. That's when you know you've got it. We draw our line, we draw our lens. I forgot what it was, a 12 diopter lens. It says a plus 12, so you know it's a, it's going to be a converging lens because it's plus 12. That's our power. Okay, here's our object, which is whatever distance away. What do we say? I think we said 50.5. My pen sucks. 0.5 meters. This one's bad too. And he's saying, how far away does our image go if we move our object 40 centimeters this direction, or 0.4 meters? And so for this, we're just gonna have to do two different problems that we'll just do because we have to know where the image moves. So we'll figure out the image for this, for 50 meters, for the object being 50 meters away, and then we'll figure out the image distance for the object being 10.1 meters away. Okay, so simple as that. Let's do this first one. I'll try to do it all in the same picture. It's gonna get sort of messy, but it'll make it a little bit quicker for me. So object is 0.5 meters away. We will go ahead and invert that into whatever 0.5 is 2. That'll be a negative 2 is going to be our u plus d equals v. Negative 2 plus 12 is going to give us plus 10. We can immediately invert that back into a distance. 1 divided by 10 is going to be 0.1 meters. Okay, is it going to be to the left or to the right? This is a lens, so it's going to be our normal thing, positives to the right. And is it going to be, that means it's going to be a real image as well. But it's going to be to the right. It's going to be by 0.1. So 0.1 is like, not much. 0.1 meters here. It's going to be upright or inverted. And magnified or minified, we'll do our quotient. Negative 2 over 10. Positive 10 is going to give us a negative number. So that means that it's inverted. So we'll do an inversion here, and it's going to be 2/10 the size. That's less than 1 by quite a bit, so it's going to be pretty small here. Okay, so that's the first scenario. The second scenario is where this thing is moved 40 centimeters to the right, which is 10 centimeters or 0.10 meters away from the lens. So let's go ahead and do that. Now let's invert that. 1 divided by 0.1 is 10. So this is going to be a negative 10 now. Bear with me, it's going to get messy. Negative 10 plus 12 is going to give you what? That's going to give you plus 2. So we're just flipping the script here. This is, going to look symmetrical. Plus 2, flip that back into a distance. 1 divided by 2 is going to be 0.5 or 0.5 meters away. So 0.5 is going to be something like this. 0.5 meters, and it's going to be, and this is still positive, so it's still to the right, and a negative divided by positive is going to give you a negative once again, so it's still inverted. And now the magnification is going to be 10 divided by 2, which is 5 times the magnification, so it's going to be like this. This thing will not write. Okay, so the question was, how far did the image move? Well, it went from 0.1 meters to 0.5 meters. The difference is 0.4 meters or 40 centimeters. Easy peasy. Woo, that was rough, but we made it. 7 out of 25 questions down. We're that much closer to killing the optics section on the OKAPs. Y'all make sure and stay tuned for next week. We're going to get to this together. Also, make sure you're pausing the thing. Pause it, you do the question, and then you watch me do it, okay? Then you have check the answer and stuff, but you got to be doing these yourself if you're going to get anywhere. All right, peace.